Hello everyone, this video is about the application of integration. In this video we will learn how to find the area bounded by curve and lines and bounded by two curves. So let's begin. In the example number 1, we have to find the area between the curve y is equal to root 5 minus x square and the y is equal to mod x minus 1. So here the y is equal to root 5 minus x square is a semicircle whose radius is root 5. And the line y is equal to mod x minus 1 is x minus 1 when x is greater than 1 and minus x minus 1 when x is less than 1. Now we have to find out the intersection point of this curve and the line. So we put y is equal to plus x minus 1 in this curve, y is equal to root 5 minus x square. We get the intersection point A and B. Therefore the intersection point is A is 2 1 and the point B is minus 1 and 2, and the required area is integration from minus 1 to 2 of the circle, the area under the circle, and we don't need the area below this line, so we subtract the area below this line from minus 1 to 1 and from minus 1 to 2. So we write here my integration minus 1 to 1, the line minus x plus 1 dx, and minus integration from 1 to 2 x minus 1 dx. So putting here the value of y from the circle, so minus 1 to 2, y is 5 minus x square under root dx, minus integration from minus 1 to 1 minus x plus 1 dx, minus integration from 1 to 2 x minus 1 dx. Now integrate to this function and we calculate the area. So after integration we get x by 2 5 minus x square plus 5 by 2 sin inverse x by root 5, and the limit from minus 1 to 2, and the second integration is minus x square by 2 plus x, limit from minus 1 to 1, and the minus x square by 2 minus x, and the limit from 1 to 2. Now putting the upper limit and the lower limit, we get a is equal to, now putting the upper limit, so 2 by 2 root 5 minus x square, x is 2, so plus 5 by 2 sin inverse x is 2, so 5 by 2 sin inverse 2 upon root 5. This is the upper limit. The lower limit is minus 1, so we put lower limit is minus 1, so we have minus 1 by 2 square root of 5 minus minus 1 square plus 5 by 2 sin inverse minus 1 upon root 5. Now putting the limits in the second integration, so we have minus 1 square by 2 plus 1. Now putting the lower limit is minus 1, so again we have minus 1 by 2 minus 1, and third this 2 square is 4, so 4 by 2 minus 2, and for the lower limit, so minus 1 square by 2, so 1 by 2 minus 1. Therefore a is equal to, this 2 by 2 is 1, and root 5 minus 4 is 1, so 1 plus 5 by 2 sin inverse 2 upon root 5. This is the value of the upper limit, and the minus minus 1 by 2 root 4 means 2, square root of 4 is 2, and the plus 5 by 2 sin inverse minus 1 upon root 5. And the second term is minus of minus 1 by 2 plus 1 plus 1 by 2 plus 1, and third term is, here the plus 1 by 2 and the minus 1 by 2 is cancelled out, and third is minus 4 by 2 is 2, so 2 minus 2 minus 1 by 2, and minus minus is plus 1. So after simplify we get a is equal to 1 plus 5 by 2 sin inverse 2 upon root 5 plus 1 plus 5 by 2 sin inverse 1 upon root 5 minus 2 minus 1 by 2. Here minus 2 is cancelled out by this 1 plus 1, 2. So we have 5 by 2 take outside and club this sin inverse 2 by root 5 and the sin inverse 1 by root 5. And the minus 1 by 2. Now here using the formula sin inverse x plus sin inverse y, which is equal to sin inverse x root 1 minus y square plus y root 1 minus x square. So simply we put here x is equal to 2 upon root 5 and y is equal to 1 upon root 5. Therefore we have a is equal to 5 by 2 this sin inverse 2 by root 5 root 1 minus 1 upon root 5 square means 1 by 5 plus 1 upon root 5 and square root of 1 minus 2 by root 5 का square means 4 by 5 and minus half. Therefore a is equal to 5 by 2 and this sine inverse, you simplify this one, we get 4 by 5 plus 1 by 5 minus 1 by 2 which is equal to 5 by 2 sine inverse 5 by 5 which is equal to 1 and sine inverse 1 is pi by 2, therefore a is equal to 5 by 2 into pi by 2 minus 1 by 2. This can further written as 5 pi by 4 minus 1 by 2. So this is the final answer. In the second example, using the method of integration, find the area bounded by the curve mod x plus mod y is equal to 1. The given curve is mod x plus mod y is equal to 1 can be redefined in the form of the four straight line as x plus y is equal to 1, minus x plus y is equal to 1, minus x minus y is equal to 1 and x minus y is equal to 1. So this is the actual graph of this curve, which area is bounded by these four lines. Therefore the required area is equal to 4 times of this area ABOA, because this figure is symmetrical about the x-axis as well as the y-axis. So we write here 4 times. So take integration from 0 to 1 the line AB dx, which is equal to 0 to 1 1 minus x dx. This is the equation of the line AB. So after integration we have x minus x square by 2 from 0 to 1 is equal to 1 minus 1 by 2. Put the 4 everywhere which was left out. So this is equal to 4 into 1 by 2 and that is equal to 2 square units. In example 3, find the area bounded by the curve y is equal to cos x between x is equal to 0 and x is equal to 2 pi. So from this graph the required area is equal to the area of OABO plus area of the region BCDB and the plus area of the region DEFT. This is the graph of this cos function, and therefore the A is equal to from 0 to pi by 2 cos x dx plus we take the mod function because the shaded region is below the x-axis. So the integration from pi by 2 to 3 pi by 2 cos x dx plus integration from 3 pi by 2 to 2 pi of the cos x dx. Now the integration of the cos x is sin x. So sin x limit from 0 to pi by 2 plus again integration of cos x is sin x. So we put this into in mod. So in mod sin x from pi by 2 to 3 pi by 2 plus again integration of the cos x is sin x So we write here the plus sine x from 3 pi by 2 to 2 pi. Now putting the upper value and the lower value, we get sine pi by 2 minus sine 0 plus sine 3 pi by 2 minus sine pi by 2 within mod and sine 2 pi minus sine 3 pi by 2 . We know that the value of sine pi by 2 is 1 and the sine 3 pi by 2 is minus 1. So put the value of this sine pi by 2 is 1 and sine 0 is 0. So we have 1 plus within mod minus 1 minus sine pi by 2 is 1 and plus sine 2 pi is 0. So we put here 0 minus within bracket minus 1. So this is equal to 1 plus 2 plus 1, which is equal to 4 square unit. Thank you.